Welcome class, and thank you for joining me for our first flipped classroom video. So, just before we get started, a couple of things I want to remind you of to point out on how to be an effective video watcher. First of all, please make sure your notes are out in front of you. You need that note packet, and you need something to write with, obviously, so you can take your notes. Another good idea, something that I recommend as you're watching these, is have a calculator sitting out next to you, okay? Because as I'm doing calculations, often it's important that you know how to get those numbers, okay? Calculator technique, if you will. So again, having that calculator out is essential so you can be following along so you don't come back to class confused on how I was getting some of these numbers as I'm running through calculations. Now, for this first video, we're going to do something pretty basic. We're going to talk about patterns and expressions, okay? Something that's more of a review just to kind of ease you into the school year. Now, something I do want to point out that's in every one of my videos is if you notice after the title of the lesson, I always include this learning target piece right here, okay? So that learning target piece is something you'll see in every one of my videos. You'll see on every worksheet I make for you. You'll see posted in the classroom. You'll hear me talk about it. It's very critical that you see and think about that learning target. Have it in the back of your mind because that is what you need to be able to do by the end of the lesson, okay? If you get through the video and you feel like you can't explain that learning target, that you don't know it, that's something, come to me and I'll explain these concepts in a different way for you, okay? But that's what you need to be walking away from this video with. So let's dive right in. So before we get started, I just want to talk about some vocabulary. So when I use these words, you understand what I'm saying, okay? Because the basis of math, you need that common language, the common vocabulary. So the first word, a variable, is a symbol, usually a letter that represents one or more numbers. So when we're trying to express these patterns, you're going to notice we're going to be using a variable, okay? That variable being whatever term it is in the pattern. Now, the next thing that I want you to know, a numerical expression is a mathematical phrase that contains numbers and operation symbols. Now again, when we're talking about representing patterns, we're going to be writing expressions to represent those calculations. And finally, an algebraic expression is a mathematical phrase that contains one or more variable. So the difference being a numerical expression is something you can calculate. So that 3 plus 5, you can calculate and tell me that that's 8. Now, an algebraic expression is involving a variable. So you can't calculate that until I tell you what that variable is representing, what number it is in that instance. Now, let's get going on actually identifying patterns. So look at the figures from left to right. What is the pattern? What would the next figure in the pattern look like? All right, so coming from geometry, hopefully this is something that you could probably just roll off the tongue. So the first figure, second figure, third figure, fourth figure, something I hope that you see developing. This first figure has 3 sides to it, okay? Also known as a triangle. Second one has 4 sides, which is a square. Next one has 5 sides, which is a pentagon. Next one, 6 sides, which is a heptagon. So again, hopefully that's something that's pretty easy to recognize. What's happening in this pattern? Every figure has another side. So what would the next figure look like? Well, the next figure would have 7 sides. It would be a heptagon. If I asked you for the next one, that would be 8 sides, or an octagon, okay? So again, this is all about pattern recognition. When it's something visual, hopefully that's bringing you back to your geometry skills a little bit. Most of today is going to be with numbers and expressions, but again, don't be scared of these patterns that you may come across. All right, flip the page. So this next one is visual, but we are going to be throwing some numbers into it this time. So use a pattern to answer each question. So how many toothpicks are going to be in the 20th figure? Well, for that, we have some processing to do, okay? We need to figure out first, before we can answer how many are in the 20th figure, we need to figure out how many, or how many are in each figure that we're given so we can start processing a pattern. So if you notice in these tables, first they're giving us a figure number. So we have the first, second, and third figure. So let's count to start off with how many toothpicks are in each figure. So in this first one, two, three, four, we have 4 toothpicks to start off with. In the next one, we have those same 4, but now notice, now we have 4 more. So we have 8 toothpicks. In this pattern, I have those 8, and now I have 4 more even. So I want you to think about what pattern is forming here. So the process that I'm going through is, notice, to go between these, I am adding 4 each time. Okay? Now, something that you are very, very familiar with, you learned this back 8th grade, probably even 7th grade, is linear things. When you are adding the same amount consistently, that rate of change. So when you recognize these patterns where I am adding the same thing over and over and over again, that is creating a line, okay? So to express these lines, okay, remember that basic y equals mx plus b, right? So for creating an expression to represent this pattern, since I know it's linear, because I know I'm adding the same thing over and over and over again, definition of linear, what am I looking for? Well, first, I need the slope, okay? I need how much is it changing by every time. Well, here, let me change colors to make this more obvious what I'm doing. Cool thing is, I've already figured that out from my process column. I know that I'm adding 4 every time. So now here, if you notice, we're going to be using n's. So I'm going to switch, instead of x's, I'm going to use n's. Don't let that throw you for a loop. Same thing, if you accidentally write x, I'm not going to get mad at you. And now we need that y-intercept. So remember the y-intercept, that is the initial point. That is when the variable is 0, what is the value? So for that, essentially, I always think of it as taking a step backward. What would the previous term be? That's going to be that y-intercept, that initial value, okay? Well, in this case, if I subtract 4, I'm landing at 0, okay? So do I need to really show plus 0? Hopefully you guys can respond with no, you really don't. So that is how I can represent each of these terms, okay? To find the amount of toothpicks in any given figure, all I have to do is take that figure number, multiply it by 4, and that's how many I'm getting. So here, how many toothpicks are in the 20th figure? Well, I take 20, multiply it by 4, there's going to be 80 toothpicks in that figure. All right, what expression describes the number of toothpicks in the nth figure? Well, we don't have anything more to do here. Didn't we do that in the first part? I already calculated that to figure out how many there are in that nth figure is 4 times n, okay? 4 times that figure number. All right, so let's look at this one. How many tiles are in the 25th figure of this pattern? All right, so we're talking about tiles. So kind of like the last one, I'm going to do the figure number compared to number of tiles. So in the first figure, how many tiles do I have? I have 4 tiles. Second figure, how many tiles do I have? I have 6 tiles. In my third figure, how many tiles do I have? I have 8. Hopefully you see something similar to the last one. Do you notice that process that's happening? All I'm doing is I'm adding 2 more tiles every single time, okay? So if I'm going to represent this, now that I understand, since I'm adding the same thing every time, I understand I can use that linear representation. So the mx plus b pattern, except remember we're going to use n instead of x because we're talking about patterns. So remember, the cool thing is those 2's are the m that I need. Now, my b, that initial value, that value where I take a step back, well, if I take a step back, that would leave me with 2. So I'm going to have 2n plus 2 to represent my pattern. So now that I have that, now I can take any figure, plug that in, that'll be how many tiles are in that figure. So if I want to know how many are in the 25th figure, I just plug in 25. 2 times 25, so 50 plus 2, there will be 52 tiles in that figure, in the 25th figure. Moving right along. So here we have some that are just simply numerical, okay? I have a list of numbers and I want to find the next 3 terms. And obviously I want to be able to identify the pattern, okay? Now, in this case, when it just says identify a pattern, that means you can actually just tell me in words, okay? If it says what is the expression, then I expect a formula for it. So here, in letter A, what am I doing to go from term to term? Well, again, the first thing I would check is, am I adding consistently, okay? Usually best line of attack, look at that, okay? So I'm adding 2 every time. So adding 2, so what would that make my next 3 terms? Well, that would make my next 3 terms 10, 12, and 14. All right, looking at letter B. Now something you'll notice about letter B that you can probably tell right off the bat, adding is not going to work, okay? Adding is not what I'm doing in this one. But notice what is happening. Aren't I just multiplying by 4 every time? So again, for these ones where it just says identify a pattern, you can just write me in words the pattern. And now to find the next 3 terms, well, the next 3 terms are going to be 256, 1024, and 4096. All right, as simple as that, just recognizing the pattern. All right, so letter C. So letter C again, first line of attack is going to be figuring out if I'm adding something. Now here, when you're checking that adding pattern, you're not adding the same thing every time, are you? However, there is kind of an adding pattern here because aren't we just adding 1 more every time? So we're adding 1 more than we did in the previous term. Okay, so we're adding 1 more each time. So That means to go to the next one, I'm going to add 10. To go to the next one, I'm going to add 11. Oh, sorry. To go to the next one, I'm going to add 12. Okay? So sometimes you'll see kind of interesting patterns like that where maybe you're not adding the same thing every time, but there's a pattern to what you're adding. Okay? So don't get lost by that. All right, now in letter D. So letter D, you'll notice here you see a multiplication pattern, right? But then that 0 there, that 0 is a little bit interesting, okay? Because it's not technically following multiplication then, because 0 times 2 doesn't give you 2, even though it works for the rest of the pattern. So I want to introduce another key concept to you, the idea of exponents. Okay, so this is 2 to the 0 power, 2 to the first power, 2 to the second power, so on and so forth. So sometimes powers can be disguised in this multiplication one, okay? So our pattern here, we don't want to say multiplying by 2 because that's not really the case, okay? It's powers of 2. That is how we make this pattern. So we need 2 to the 5th is 32. 2 to the 6th, 64. 2 to the 7th, 128. All right, last one of this type. Now this is my favorite pattern. This one is a really, really interesting pattern to me, okay? So it's a little bit tricky to see at first, but I want you to notice something. 1 plus 2 gives me 3, right? And then I want you to notice 2 plus 3 gives me that 5. 3 plus 5 gives me 8. This is actually a very particular, very unique sequence of numbers, okay? It's actually called the Fibonacci sequence. And what it does, it starts with 1 and 1, and then all you do to create the next number in the sequence is you add the previous 2 numbers. All right? So if we're being asked to follow this sequence, that means to find my next term, I need to take 5 plus 8 to get 13. I need to take 8 plus 13 to get 21. I need to take 13 plus 21 to get 34. All right, so that one is difficult for students the first time they see it to recognize, but it is a very cool, very important sequence. All right, so let's flip the page again. So 2 more examples and then I will let you go. So you can also see patterns when it comes to graphs. All right, so you want to set up an aquarium and need to determine what size of tank to buy. The graph shows tank sizes using a rule that relates the capacity of the tank to the combined lengths of the fish it can hold. If you want 5 2-inch platies, 4 1-inch guppies, and a 3-inch loach, what is the smallest capacity tank you can buy? 15-gallon, 20-gallon, or 25-gallon? And it wants us to use the table to find the answer. So here's tank sizes, all right? So looking at this graph, there's two ways you can do this, okay? So you know how to find equations of graphs, okay? We already talked about that y equals mx plus b, all right? So that starting value is your b. My slope, let's see, up 1 over 1. So my equation is going to be x plus 2, all right? Now, just to show you, you could use some points from the actual one, and you could find a pattern that way. However, if you're given the graph, it's very easy, just get it from the graph as well, okay? You know how to find the equations of lines, so why not do so? Now, finding the pattern was only part of it, right? That's just kind of our tool to answer the question. What was the actual question? Well, the actual question is we need to combine these lengths. So we want 5 2-inch platies, so that's going to be 10, 4 1-inch guppy, so that's 4, and a 3-inch louch. So we're talking about 17 inches worth of fish. Because remember, it said it's the combined lengths of these fish. Okay? So what do I need to do? Well, I can plug that in to my expression now. The expression relating these two things. So 1 times 17 plus 2. So I'm going to need a capacity of 19. And I really should include with that the label. So we're talking about a 19-gallon tank for those fish that I need. Okay? Let's see if we miss anything. We are good. So, last example before I let you go. The graph shows the total cost of platies at the aquarium shop. How much do 6 of them cost? And it wants us to use the table. All right, so again, we can use a table. However, when we're talking about something graphical, you know how to write expressions from graphs. You know how to write the equation of a line. So if it's easier for you than doing that table method, I want to show you again, this is a line. So you could very easily take the y-intercept. So your b is 0. That slope, rise of 2, run of 1. So your slope is 2. Or again, that would be what you're adding every term in the table. And you can write this expression for me. And again, do you need the 0? Not really. And then you can say, oh, I want 6 of them. So 2 times 6, they're going to cost $12. All right. So you've been shown a lot of methods in this video, okay? I've shown you how to do it with patterns, how to do it with tables, how to do it with graphs, all right? So that's going to be the end of our video for today. Now, I do want you to note the summary at the bottom, okay? When you come back, we're going to discuss, and I'm going to model for you how to make a good summary of these notes that you can use to help you study for my tests, all right? But you don't need to worry about that for now. Just, you can wrap this up, call it done for the night, and then come back tomorrow and I'll show you how to finish up that final piece of this video. So again, thank you for joining me, and I look forward to discussing how to write those summaries with you in class.